In this video, we are going to be looking at using algebra tiles to express the area of a rectangle, but we're also going to be looking at it in two different ways. As a product, which is multiplication, and as a sum, which is addition. So we're going to be trying to look at it in two different ways, and we're going to use algebra tiles to express it. So in this instance, you can notice that this is the rectangle that I am given. And I have some pieces labeled, but I really need to label the rest of it. And that includes the perimeter of it. So I have XY here, and I know this right here is the length of Y. So these are all Y. And I know that then that this length right here is Y. This length right here is Y. Because this right here is XY, what times X or what times Y is XY? Well, X. So this right here must be X. To get the area of this rectangle piece here to be Y, it means I'm multiplying by 1. So these are each 1 in length. Now if I go to the other side, we should have it mimicked. So you should see here that this should also be 1 over here. And this right here should be X. If I'm going to fill in the rest of these, it might seem a little tricky, but it's not too bad. So if I'm looking at this rectangle that's filled in right here, it says that's an X. This must also be an X. So that leads me to believe here that I have a square, and it's a perfect square, which means that the lengths have to be the same. So if this length right here is X, this length right here must also be X. So therefore, this is X times X, which is X squared. The lengths here then must also be X. So each of these bars right here are also X. And that leaves the squares right here. So anytime we have squares, we know that these are units of 1. So each one of these represents 1. So this represents 1 here and 1 here in length. So now we started out by labeling everything because it makes it a lot easier when we're breaking things down. So now I need to write it as a product and as a sum. So let's start with the sum because it's a little bit easier. The sum means I'm adding up all of the pieces inside. So if I count, I have 1, 2, 3, 4 Y's. All right. I have an XY. I have 1, 2, 3, 4 X's here. I have an X squared underneath. And then I have these 2 additional X's. And then I have 2, 4, 6, 8 1's. So now I need to simplify my expression and rewrite it in a way that makes sense. So again, in math, we like to start with usually alphabetical order and also the highest exponent. So we have X squared is going to be our leader for this. It's X first, and then it's also squared, which means it has the highest exponent. So I can rewrite this as X squared. Then I would look for X only. So 4X plus 2X is 6X. And then I'm left with XY, then to 4Y, and then to 8. So this right here is what I'm looking at for my sum. This is my area as a sum. And then my next thing is going to be area as a product. So area as a product means that I'm looking for multiplication. So if you think about it, if I were looking at a regular rectangle, to find the area of a rectangle, I want to do my width times my length, right? So this is area equals length times width or width times length. The same idea is going to apply for this. So I can define this entire edge right here as X plus 1, 2, 3, 4. So this is x plus 4. My width, I'm going to say my width is x plus 4. And now I'm going to look at my length. So my length here, as you can see, is y plus x plus 1 plus 1. So this length right here is y plus x plus 2. Now I'm going to rearrange the order that that's in because, again, we would like to keep it as alphabetical. So it'd be x, then y. So my length, I can say, is x plus y plus 2. So when I write this as a product, if I have area is equal to length times width, then I can say that my area is equal to x plus 4 times x plus y plus 2, where our width is x plus 4 and our length is x plus y plus 2.